Hello again, everybody. This is Joseph. This is a tutorial dealing with Hondas. Before we were doing Toyotas, Honda Civics, Accords, and there's something that I wanted to bring and compare and show you. Once you know one schematic from make and model, pretty much you can figure out another schematic from another make and model. If we knew Toyotas, we went over Toyotas, we went over GM, Chevys, also BMWs. Honda is all have the same principle, how they start. They all have to have a starter motor, right? They all have to have a battery. They all have to have fuses. The way they do it can be a little different, but the idea, the concept is the same. The computer might have control of it in some models. Nevertheless, once you know one, you know the others. And we'll get to it in a second, and you'll see what I'm talking about. Where do we start with? Let's say I want to start from start a solenoid, start a motor. Okay? I can't start the car. I'm thinking to myself, can it be the starter? Can it be maybe a fuse is out? Right? Maybe a fusible link is out. Can it be the ignition switch? Can it be the gear position switch causing a problem? Now, the reason why I mentioned these things is previously when we did Toyotas, you notice the schematics were a little more complicated to figure out. Honda's, the battery is over here. Before we had the batteries up here. It doesn't matter. The purpose is the same. The battery is always the same purpose. To give current to flow by a voltage, by a pressure. So therefore, where would we start? We know that 12 volts has to go to the starter motor, but before that, it has to be engaged. That happens by a solenoid. So we have to go back to the path up here. Now, this is the point that I wanted to make. If you recall before, which position in the ignition switch do you start the starter motor? It can only be one position. That position in the start position. Can you tell me why? And figure out from this diagram why that is. If you look at any other positions, lock, accessories, on, which is like in the run position, there is no connection. You don't see any wires. In which position do you see wires or connections? That's in the start. There's a reason for that. Because we want to start the starter motor in this position. Then we go to run or ignition for Toyota. It's the same concept. We always start with start to start the starter motor. Once we engaged it with the engine being cranked, then we go to run. So, is it different from the other ones? No, same concept. You still need an ignition switch like Chevys, like BMW. You still need it in every car, right? Same concept so far. So, started from the battery, right? As remember you call 6 cells. Same thing as other make and models. Also 6 cells. Why? Because each cell is 2.1 volts. 2.1 times 6 gives you 12.6, which is the voltage of a good charged battery. Depending, of course, on the heat and the temperature. The ambience temperature. We're going through here, we're going through a fuse. And this is not a fusible link, this is a fuse. What's the rating? 80 amps. So we went from here, black and white, to a wire that's black, through a fuse, come out the other side. Go through another jumper, right? Go to another fuse. How much is this rating? 40 amps. Went from 80 amps to 40 amps. Fine. What's the color of the wire? White and black. We continue along. See the arrows that I have? Again, still white and black. We didn't lose it. White and black, same wire. Then we go through a little connection that gives us a white wire. Fine. Doesn't matter. Current doesn't care what color the wires are. We have to go through the ignition switch. We come out from this one, this terminal. What's this? Black and white wire. We come here. Again, black and white wire. Now, if you remember in the Toyotas, what we spoke about also. This is why somebody asked me how come I don't make schematics for every make and model, every possible thing, engine control, because I would have literally thousands and thousands of videos to make. The idea that I'm getting with is, if you know the principle, if you know the origin of one, you should be able to figure out the other one. It takes dedication and practice and sometimes hard work to understand and interpret schematics. But as you can see, and I'm going to prove it to you, basically the same as Toyota. The reason I bring this up is, you remember in Toyota we had a module. You're not sure what this says, W/W/0. Do you remember in Toyota it means with anti-theft? W/L means without anti-theft. Whenever you see that, you have two branches, two paths of current that you can follow. If you have the anti-theft, you will follow this path up here, the black and yellow wire. Okay? If you do not have the anti-theft, you will follow this path, as I color-coded it with green. So we went from a black and white wire, or black and yellow, again, to the same black and white, right? Again, we're following the one without anti-theft. If we'd be following the one with anti-theft, we go up here, we would be going through a relay. A relay. So, as you can see why, because this is security starter cut relay. The other side of it goes through a security system, security control unit, like an anti-theft that I made a video about. Same idea, same principle. So, going back again, we're following the one that does not have anti-theft. Which one are we going to follow? This one or this one? This one. Come out here. Which one are you going to follow here? Now, this one or this one? This one. Come out here. Right? White, orange wire. Without anti-theft. Again, black and white wire. Right? Whenever you see a slash, that means there's two colors, like a stripe, to that wire. Right? We come down here. Now, if you remember, what we said before was, we need the gear shift to be in either in one of two positions to start it, to start a motor, to start the car. If you remember, those positions were neutral and park. Anything else, drive or another gear, the switch, if the switch is in that, will not activate the starter motor, will not start the car. Same in Chevy, same in Toyota, Lexus, Camry, same idea. That's why if you know it in that one, you'll know it when you see it over here. That's why I have neutral connected and I have the park connected. So whichever it is, it's park. Come down here again. Now the wire changed to black and red. Right? Black and red, now it became black and white. Regardless of that fact. Now we go to the solenoid to engage the starter motor. What I'm trying to specify is, and then you have current flowing to the starter motor once this engages this starter motor by the solenoids. Isn't the principle the same as Toyotas? Go look at the videos from Toyotas. Go look at the videos from Chevy. Go look at the videos from Ford. Any of them. Still need a starter motor. Still need an ignition switch. Still need your gear position to be in neutral or park. Now, let's go to something different. What I was specifying about yesterday. Remember yesterday I made a video, or 2 days ago I made a video, I believe, and it was about your dashboard, your instrument cluster they call it, or Toyota combination meter they call it. And I said to you, once you turn on the key, you see all the lights coming on, almost like a boot up to see all the lights, the bulbs coming on, testing the system. And I mentioned there are bulbs. This is a symbol for a bulb. Each bulb has its purpose, obviously. One for the brake system indicator, one for the low fuel indicator, as we always see when we turn on the car. These are bulbs for other things, right? ABS, cruise control. Then we have the gauges. So the gauges are here, And the gauges also need one thing that I stress, 12 volts. All these things work on 12 volts, if you remember or recall. So it's the same concept. Engine coolant temperature goes by a thermistor, right? Engine coolant temperature. This thermistor, this resistance changes with temperature. It goes lower. They call it negative coefficient. Anyway, that will give you on the gauge the coolant temperature, how hot the engine is getting. Usually we want it in the middle. Sometimes you have the numbers, 210, sometimes you just have in the middle. Sound. Now, fuel gauge also. I asked you a question, I said, how do I know which line is going to the 12 volts? Well, if you look over here, I told you it's a common bus line. Follow the common bus line. See, connection here, connection here, connection here. Connection here, connection here, here. That means this is a common bus line. That means, all probable cause, this is coming from the 12 volts. Is it true? Let's follow it. What do we go with? We're going through this connector, junction connector. And sure enough, here it is. We're going to the fuse to the 12 volts. So, what I said before for other makes and models, isn't it true doesn't hold for Hondas? See, it's the same concept. You don't have to make 1,000 videos for each the individual make and model of everyone. I give you the overall view, general view of one, and from that hopefully you can figure out the rest. Same thing, we also need bulbs to light, we also need gauges. It doesn't matter what car it is, right? Some might be digital, some might be analog, doesn't matter. We still work on 12 volts from the battery, right? And again, we follow the line with all this common bus line. We go here, and sure enough, it comes through this and through this. These other ones from the 12 volts feed the other ones that we just talked about. The cruise control is fed by the 12 volts. This is fed by the 12 volts. This is fed by the 12 volts. All this is fed by the 12 volts. Okay? So, obviously, if all lights do not light and the gauges do not light, what am I missing? I come over here, right? Probably the fuse is not good. Maybe the battery is low, right? If your battery is low, do not expect to turn on the lights or to crank the engine. If you cannot turn on the lights, which is about maybe 12 amps, something like that, maybe 15 amps, whatever it is, don't think of trying to turn on an engine which requires about maybe 200 amps or more, depending how many cylinders you have. It will never happen, right? The fact that you turn on the lights doesn't necessarily mean I can turn on the engine, and vice versa. So, if you have no lights, again, in the instrument panel, in the dashboard, right? You probably don't even have 11 volts. You probably have like 10.6 volts. The lights don't even come on. Psh, forget it. That's about 12 amps. You can't even crank 12 amps. Don't think about cranking 200 amps or whatever you need. All right? One more to go over. Again, and a point to be made. I was talking about your car doesn't start. Besides the starter motor, besides the computer having control over the fuel pump, fuel injectors that we went over, ignition coils, if the camshaft or the crankshaft do not give signals that the camshaft or the engine is rotating, right, creating revolutions, that computer will shut down that car. Why? Because if the camshaft is not turning, the crankshaft is not turning, there's no purpose of going and putting fuel into the cylinders or a spark. So if you have a bad camshaft sensor or if you have a bad crankshaft sensor, the computer says, okay, there's a problem. I don't see revolutions. That tells me that something is going on. Malfunction switch, a light comes on. Over here, malfunction indicator. And where is this coming from? Comes from the computer, engine control system. It's the computer is monitoring everything, every single thing once you turn on the key. Even before you turn on the key, the computer controls everything. And it sees and it says, okay, engine is not turning. I'm not going to let the fuel injectors allow fuel into the cylinders. I'm not going to allow the ignition coil to fire a spark. There's no reason for it. But the computer doesn't know that the camshaft sensor is bad or the crankshaft sensor is bad until you figure it out yourself. Right? It just sees no signal from those sensors. Can't turn on the engine. No reason for it. No reason for it, right? One more diagram. Now, this is a little straightforward, but now this is basic electronics, so to say. You turn on the lights. When do you turn on lights? Interior lights. You see this? This is for the interior lights. Again, hot at all times. That means this is connected all the time. All I have to do is close the switch. Now, if you notice, over here, it says ceiling light. You have a light in the ceiling, right, of your car. Okay? Now, a couple of things to understand here. You have a light in the trunk, obviously. You have a light in the ceiling, like we just said. And we have lights for the doors. Now, the question arises, and see, we have two paths over here. We know current will flow in two paths. But we need a complete circuit to flow. Looking from this, when can current flow? This is the light in the trunk light. When will current flow? When current flows to ground. What allows this current to flow through ground? The switch. Where is the switch located? The trunk latch switch. When I open up the trunk, right, that's when I need the light so I can see what's going on in the trunk. So actually, I'm closing this switch, allowing the current to go to ground, allowing the other side of this light to be connected to ground. That's number one before we troubleshoot. Number two, the ceiling unit. Usually there's a switch for it to turn on the ceiling lights. Right? Where is that switch over here in the schematic? Right? This trunk latch switch is in the trunk. You don't turn on the switch. Right? Unless in the front you have in the panel, you turn on to open the switch. That'll open up the hood, right? And then the light comes on. So actually, when you're turning on, when you're about to activate to open the trunk with this switch, what you're doing is you're also opening or activating the light inside the trunk. Now, other thing is, we just said there's a ceiling light. This has to find the ground, just like this found the ground when this was closed, when I wanted to open the trunk. This over here, where's the ground? Right here. This is the ground. Current can flow. We're not talking about this path anymore. This is for the trunk. We need the ceiling lights on. Here, and right to ground. 12 volts here. How much over here? 0 volts. Why 0 volts? This is connected to ground. The whole voltage drop is across this bulb. How do I know? If 0 volts here, 12 volts here, that means I have 12 volts across here. If I have 12 volts across here, this is connected to ground. How much do I have? 0 volts is connected to ground. The doors. How many doors? 1, 2, 3, 4, right? Civic, whatever, right? Now, when do I see the light? When I open the door, the light comes on, doesn't it? Right? When I close the door, the light comes off. We don't want the light on when we're driving with the doors closed, right? So therefore, obviously there's a switch in the door that allows that to be happening. Right? One for the passenger, one for the driver, one for the rear, left and right, two in the back. So instead of this one that we're turning on the ceiling light, right, we're going to be turning on the door, right? The switch goes to the door. We follow this path again. Now, if you notice, this is all the only thing that's a little different. USA over here, these are the models that it start with. Usually it starts with CX, DX are the models, and all Canadian models. USA, LX, if you have LX something, if you have EX something, and HX something, you'll follow this path. If you have Canadian cars and USA cars, you'll follow this path. If you have USA starting with LX, EX, and all this, you start this path. That's all it is, okay? So let's say we have a Canadian car. It doesn't matter. We said current will flow, not here. We didn't close the switch, so it's not going to ground. It's continuing going here. From one side of the switch to the other side. The other side comes out here, right? Light green, blue. Light green, blue. Light green, blue. Coming down here. Now, I'm gonna open my door. Guess what? When I'm opening my door, I'm actually closing the switch. When I'm closing my switch, guess what? I'm giving a ground to the bulb. The bulb will light. I'm opening the passenger door, or the passenger's opening the door, actually closing the switch. What does that do? Again, a ground. And the same for the rear. So when I open the door, I want the light to come on, right? Light comes on, boom. That's when the switch is actually closed electronically, physically. Then the light comes on. Same as this almost. Right? Same as this. The light comes on. How much would I measure here? 12 volts. How much would I measure here when I open the door, which I close the switch? 0 volts. Now, for troubleshooting, if I come over here, one side of the bulb, and I measure 12 volts, that's good. What does it mean? That means I'm connected through the bulb to the battery. That's great. How much should I expect over here? Well, isn't it the same as this example? I'm connected to ground. So if this is connected to ground, it should be 0. But let's say I don't measure 0. Let's say I want to put the ceiling light on. That means I have to activate the switch in this position. But let's say the switch is broken. Right? It's not making contact to ground. How much would I measure over here? Guess what? 12 volts. Why 12 volts? You're going to say, Joseph, didn't you measure 12 volts over here? So now you measure 12 volts over here also? Because there's no current flowing. How do you have a path for it to flow? If this is open, it's not going to ground. There's no voltage drop. If I have 12 volts here, 12 volts here, I'm connected to the battery, but this side is not connected to ground, pulling it down to 0 volts. So 12 volts here, 12 volts